In this video, we're going to look at combinations and probability. Use combinations to calculate the following probabilities. Write your answers as percents rounded to 3 decimal places. So let's read the first question. A poker hand has 5 cards, and order of the cards does not matter. How many 5-card poker hands are there? Well, since the order does not matter, we know it's a combination. There are a total of 52 cards in a deck. So, using this formula, the number of permutations is 52 times 51 times 50 times 49 times 48. So let's write this over here. So 52 choose 5 equals 52 P5 over 5 factorial. So that's equal to, I've computed 5 factorial up here, so we have it. That's all the factors from 5 down to 1, and that's 120. And now let's find this product on the calculator. So, starting with 52, we're going to count down 5 factors. 50, 49, 48. And I'm going to do us a favor. Let's not write that down. Let's just go ahead and divide by 120 because that will make it smaller. And we get 2,598,960. 2,598,960. Okay, so that's a lot of different 5-card poker hands, which is what makes the game so interesting. So this will be our sample space for the next few problems, and then we'll find the probability of getting different types of poker hands. So here, the next one, we have a flush is a 5-card poker hand where all the cards have the same suit. And we're asked, what is the probability of drawing a flush that is all clubs? So we know the denominator is 52 choose 5. It's the size of the sample space. So now let's see how many ways there are to draw. So we have 13 clubs, so there's 13 of any suit, and we're going to choose 5 of them. Okay, this will be the permutations. So 13 times 12 times 11 times 10 times 9. Okay, and then to find the number of combinations, we divide this by 5 factorial. So 13C5 equals 13P5 over 120. Let's find this on the calculator. So 13 times 12 times 11 times 10 times 9. Divided by 120. So there are 1,287 possible hands that are all flushes, all clubs. And now I'll put a times here. This is going to be a small number. So let's write it as a percent divided by 2,598,960 times 100, and round to 3 decimal places is 0.49. The 5 rounds up, the 4 to 5, so it's 0.05%. So very unlikely. The next question asks, what is the probability of drawing a flush of any suit? Okay, so here we specifically found a flush that was all clubs. Now we're looking at drawing a flush of any suit. Well, notice that we can use a lot of our last work because flush of any suit, there's 4 different suits, and there's 4 ways to pick a suit. So we can multiply this previous result times 4. So 4 times, it'd be like if we added this up 4 times, but we're not going to use the rounded version. We'll go back to the calculator. 1287 times 52, choose 5, times 100%. So multiplying this by 4 for the 4 different suits to 3 decimal places is 0.198%. 0.198%. Okay. If we multiplied this by 4, we would have gotten 0.2, which is close, but this one is more accurate. So it's good to go back to your calculator and round at the end of your computations. Let's look at the next one. A 4 of a kind is a 5-card poker hand where 4 of the cards have the same rank, so the ranks are ace, 2, 3, king, jack, blah, 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 and one other card which we call the kicker. So what is the probability of drawing a 4 of a kind with 4 aces and any other card as a kicker? Okay, so we're specifically looking at aces, and then we have to choose the kicker. So here are 4 choices. So these are going to be our aces. And then this will be the last card. So it's kind of, again, thinking of this in terms of sub-choices. Our first choice is the 4 aces, okay, and this is actually going to be a little bit boring, but it proves a point. Okay, so we have 4 choices for the first ace, 3 for the second, 2 for the third, 1 for the fourth. But remember, this is the permutations, so we want 4c4, which is 4p4 divided by 4 factorial. Well, this is 4p4, 4 times 3 times 2 times 1. Well, 4 factorial means the same thing, 4 times 3 times 2 times 1. So there's one way. Okay, so if you think about it, how many ways are there to choose the 4 aces, 4 of the 4 aces? Well, there's one way. Okay, so now for the kicker, we can't choose any aces. We already chose them all. So if we subtract the 4 aces from the total, we get 48. Okay, so let me just put that this is divided by 4 factorial so we don't get confused. And the kicker, we could say it's 48, choose 1, or just 48. So for this probability, we have 48 over the sample size. So here's the sample size times 100%. So this is going to be very teeny, 48 out of 2.6 million. So 48 divided by 2598960 times 100. To 3 decimal places, the 8 would round up the 1 to a 2, so it's 0.002%. So it's very unlikely to get a 4 of a kind that are all aces. Now let's look at the last one. A full house is a 5-card poker hand where 3 of the cards are of one rank and the 2 other cards are of another rank. So what is the probability of drawing a full house that is 3 tens and 2 jacks? So this is a specific full house, just like this was a specific 4 of a kind with aces. We're looking at 3 tens and 2 jacks. Okay, so again, we're going to think of this as 2 choices. We're going to choose the tens. And then we're going to choose 2 of the jacks. And then we're going to find the product. Okay, so here there's 4 tens and 4 jacks. I'm going to actually write this a little bit higher. So we have 4 choices, then 3, then 2. But remember, this is a combination, so we would divide by 3 factorial. Okay, so this is the number of ways to choose 3 tens, and the number of ways to choose 2 jacks. Well, we have 4 jacks, so it's 4 times 3 over 2 factorial. Okay, and then we'd multiply these results. Okay, so this is, in our fancy notation, 4 choose 3, so choose 3 of the 4 tens, and then times 4 choose 2 of the 4 jacks, divided by 52, choose 5, which is this huge number. And then we're going to multiply that by 100%. Okay, let's find these two separately first. So let's get our answer spot ready. This is 4 times 3 times 2 over 3 times 2 times 1. Notice the 3's and 2's cancel. And so there are 4 ways to choose 3 tens. And that makes sense. You could think of it as there are 4 ways to not choose one of the tens. Now let's look at the jacks. So 4 times 3 over 2 times 1 is 12 divided by 2, which is 6. Okay, so the product of these two on top is 6 times 4, which is 24. Okay, so now let's go to the calculator. Okay, this is going to be, half the size of the previous one, so we should get about 0.001%. I'm not sure though because of the rounding. 24 divided by 2598960 times 100. So notice it's giving us the e to the negative 4. Let me write this up on top so I could show you how to do this. Okay, so I'm going to go, let's go 3 decimal places out, so 9.23. And the e to the negative 4 means that the decimal place should be, to get the actual number, should be moved 4 places to the left. So that's 1 place, 2, 3, 4. So here's a decimal point, 0.000923. Okay. So it asks for 3 decimal places. I'm tempted to do 4 because it'd be more specific, but we'll do 3. So that 9 rounds up to a 1. So we have 0.001. So 0.001%. Okay. And just something to note, you'll find a lot of your probability questions ask you for 3 or 4 decimal places just because of this. Remember, if this said round to 2 decimal places, our answer would be 0. That doesn't mean this is impossible. It just means it's nearly impossible. So we like to include at least 1 digit, and I'm satisfied with 0.001%.